So today we're going to talk about latching and set and reset. So first, latching. What is it? So what latching is it's going to keep your output on even after your input has gone off. That is our goal here. And you will use this time and time again. This is probably the one diagram, ladder logic, program, whatever you want to call it, that you're just going to have burned into your memory because you are going to use it time and time and time and time again. All right. Now, let's go ahead and give a little quick demo. So first we need a few tags. So we need a few inputs. So I'm going to go ahead with my start. I'm going to call my stop. I need an output. I'm going to go with a memory just for good measure here. And let's go ahead and make sure that all of these have the right address to them. So our output, make sure we've got that changed. Go ahead and get our memory set up correctly. All right, that'll be in. And I always like to start at 3 for memory, just for good purposes here. So, got our tag set up, and we can go ahead into our program blocks. And overall, the default latching circuit is pretty simple. We're going to have a start button, a stop button, an output, and then we need a branch around the start button. Now, in my case, I'm going to do the branch at the second place. Doesn't really matter which one you do. All right. So we have our stop, we have our start, we have our output, and our output again. And that is the standard latching circuit. Nothing too fancy about it. All it is a single line of code. So that way, as long as start and stop are both true, start can go on or off as it pleases, and it will automatically, or not automatically, but it will keep the output on. All right, so nothing too crazy here, and we'll show you how that works in a minute once my PLC is found and I can download to it. There we go. PLC has been found. We're going to load it onto that. All right, and we should be finished. So let's just go straight to the dot cam. So if I have 1 on and 0 on, you should see that my output does turn on, and I can turn 0 on or off as I deem necessary, and my output will stay on, and that is because of the latch. Let me go ahead and put my sunglasses on, go back to this setup so you can see both at the same time, and we can see how the power flows. So when nothing is on, stop and start, no power is flowing, no power gets past the stop button. All right. Even if I flip the start button on, no power flows past that stop button. So again, kind of standard code overall. Now, once I flip the stop on, all right, you can see that there are 2 different paths for electricity flow. One is through the start and one is through the output. So imagine your output actually has another relay on it or coil on or contacts on it that actually close when the output turns on. That's basically exactly what's going on here. So as soon as we flip start, you'll see that the output does turn on, and now power is flowing through stop, through start, and the output to the output. And as soon as I turn start off, power still has that capability to flow through the output. So this is our standard latching circuit. And I like to tell students that you're going to use this time and time and time again all the time. All right. And we can have as many stops here as we want. So you can just put more stops in series. And if you want to have more start buttons, you would put those in parallel. All right. So let's go ahead and go offline. So again, if you wanted to see what that would look like, you could do a bunch more stops, and then we could do another branch here. And then we could do another branch again. And you could basically just do this over and over again. You can have as many stop buttons as you want, as many start buttons as you want. So it's a nice, simple little setup. Now, let's go ahead and compare this to a set and reset setup. All right. Now I'm going to go ahead and just make a few more another start tags, start 2 and stop 2. All right. And then let's go with an output 2 as well. Output 2 as well. So the I0.2, I0.3. This should be, what is it, Q0.1, 0.1. There we go. So now we can go ahead and do a little comparison here. Now I'm going to break one of my rules, and I'm going to have multiple rungs in one network, which I really hate when students do, but there has a purpose to it, and it's less screen real estate, so that makes our life just a little bit better, for demo purposes anyway. All right, so we're going to just go ahead and do a normal output on both of these. Come on, give me a normal output. There we go. And another normal output. Now, we could have gone into bit logic operations, and then here's the S and the R. All right, so you could have done that. However, I always like to just put the normal output in, mainly because it's on the favorite bar, and then I can just double click on them and change them to a set and a reset. So that's how I like to do it. We'll go ahead and make this output 2 for both of those. Now, I always tell my students one of the few cardinal sins that you can make is using the same output on multiple rungs, which is what I am doing here, right? I have the same output tag on multiple rungs. This is one of the few times that you are actually allowed to do that. And that's because these two work as a pair. It's not like a normal line. So the set and the reset don't always force a change. All right, they only force a change when they're told to make the change. Where a normal rung of code is every time this rung is output, it's either saying the output should be 1 or 0. There's no other option. It's either on or it's off. And if any of the logic before it is false that causes it to go false, it sends a 0 out. If any logic or all logic is true enough that gets it to be true, it will send a 1 out. So this rung is always updating that tag, whether it's sending a 1 or sending a 0. It's got to send one of those two. A set and a reset do not force a change. They only force a change when they are true. So kind of a little bit of a nice logic there. Now, so as you can see, they both look pretty much the same. They both have a start button. They both have a stop button. They should both have a stop button. It helps if I actually make the code correctly. And that's not where the stop button belongs. And I think that was what my issue is. Put that in the wrong location. So they both have a start, they both have a stop, and you will see one slight differential from here. All right. I should have actually made these both the same start button and stop button, but that's okay. Let's go ahead and go online first. So you can see once we go ahead and get online, all right, that again, if I flip the start button down here, the output turns on. If I flip the start button here, the output turns on. And notice how the S and the R are both green. So those both are outputting, which we can see by the little green light on the PLC. They are outputting even though there's no green line going up to them. And that is how the set and the reset are working. They hold their state until they are told to change. And once the reset becomes true, it will be being told to change. All right. And notice again how that S went dark blue, even though that line is never changed its actual state. So just that second line. So in the long run, these two are very close. Now there is one slight difference that we do need to make. So let me go ahead and tweak that code. All right, so as you can see, I have updated the code ever so slightly. I've added in both stop buttons there. So now I can do either start button will start the system, all right, or either stop button will stop the system. And again, I have screwed up. 1 second. As I was saying, I have added the code so we have both start buttons that work. So I can flip start 1, and to kill it, I can use stop 1. I can flip start 2, and I can use stop 2. All right. So either way, I can use both start buttons and both stop buttons to do my bidding in this case. Now you will see there are some slight variations here. For starters, the start buttons are exactly the same. They are both in parallel. They are both the same symbol. So if you used makes on a braking circuit or a latching circuit, you still use makes. If you use brakes on the latching circuit, you would still use brakes. However, the stop buttons is where we alter. All right. You'll notice that we've gone from 2 stop buttons in series on the latching circuit to 2 stop buttons on parallel. We also went from makes on the latching circuit to brakes in the reset. So these aren't perfect just, oh, well, I just separate things and I'm done. No, there are some slight tweaks that you do have to do because it's not a perfect system, but that is darn close. All right. So, but this is overall how reset and set works. So you can see I hit the start button and it doesn't matter if I kill the second stop or whatever. Either way, both of them will kill the output that they're supposed to kill. So that is a little quick intro or how to use a set and a reset compared to a latching circuit.